Over the past 2 days, we've talked about trig integrals where we had just sines and cosines mixed together. And we've talked about what happens if all of the powers on sines and cosines are even, and what happens if sines and cosines have some odd powers to them. So what we're going to do for this class is we're going to mix together these ideas and then also point out the fact that these are not the only way to solve integrals that have trig functions in them. There are lots of other potential approaches to trig integrals. And just to point out the fact that don't think there's only two approaches to these problems. So we're going to see a lot of different methods. Sometimes we'll use substitution, sometimes we'll use integration by parts, sometimes we'll just have to rewrite trig things. So the goal here is not to memorize a set of processes, but rather just to get comfortable struggling with trig integrals and trying to figure out what to do with them. So you might want to try looking at these two on your own first and see what you would do with them. So with this first one, this one's sine cubed over cosine. This one's kind of like what we were doing when we talked about odd powers. Everything's raised to an odd power except for its division instead of multiplication. So if we were going to try and do u substitution here, which might be a good idea, we would need to choose our denominator to be our u because otherwise we won't be able to get a du in a denominator. So we're going to need our u to be cosine of x. So du over dx is negative sine x. Okay, and maybe u substitution is not even the correct method, so you could try other things as well. If we try this, so this is going to say du over negative sine x is dx. So if we rewrite this, we're going to end up with sine cubed x over u times du over negative sine of x. We notice that one of the signs is going to cancel out, and we can pull that negative out front. So we have negative integral sine squared x over u du. But this is not good because we still have an x in our expression. We need to get this totally in terms of u. Our u is cosine, so we want to rewrite sine squared in terms of cosine and just cosine of x, not cosine of 2x. And so since the original sign was to an odd power, this is where we might try and use the 1 minus cosine squared. And this is good because this gets us in terms of u. We wouldn't want to use that power lowering formula, the 1/2 times 1 minus cosine of 2x, because that has cosine of 2x in it, not just cosine of x, so it would not be our u. Okay, so we're going to get negative 1 minus u squared over u du, and now we can simplify. So it's negative on the outside, 1 over u squared over u is u du, so I just broke that apart into two fractions. Now I can anti-differentiate, so I'm going to have negative ln of absolute value of u. This negative and this negative will go together to give me a positive 1/2 u squared plus c, and we'll replace our u. So negative ln absolute value cosine of x plus 1/2 cosine squared x plus c. Okay, that one started out by looking a little bit different than the ones we've done before, but really turned out to be very similar to the ones where we had an odd power of sine or cosine. We just had to be a little bit creative here in making sure that we took our denominator to be our u. Okay, and again, we're just getting practice with trig integrals here. Okay, so this one has an x multiplied out front. Ooh, so we've got an x, we have a polynomial times a trig function. And what that says to me is this might need to be integration by parts because these are two functions that are not related to each other and they're not both trig functions. They're not each other's derivatives. So I think we're going to need integration by parts here. So we're going to need our u and a dv. Remember, we used lip t to choose our u. We don't have a log, we don't have an inverse trig function, but we do have a polynomial. So we're going to choose x to be our u. So our du will just be 1 dx. This makes our sine cubed x dx my dv. Oh, this is where things are going to get fun. So in order to find v, I need to integrate sine cubed x dx. Ooh, and that means I need to use the techniques from the past couple days. This is not going to be pretty. That's okay. Okay, so let's see. How would I do that? That's sine to an odd power. So maybe I could break this up into sine squared times sine. This is going to be my du eventually. I can rewrite that sine squared as 1 minus cosine squared. And then I make my u cosine. My du is negative sine. So I'm going to get negative integral 1 minus u squared du. So I'm going to have negative u plus, if I distribute that negative sign, 1/3 u cubed. Okay. This doesn't look pretty. Okay, so this means that my v from my integration by parts is negative cosine of x plus 1/3 cosine cubed x. Okay. Now we have to put this all back together. Okay, so integration by parts. uv minus the integral of v du. Okay, so we are going to do u times v. So we're going to have x times negative cosine of x plus 1/3 cosine cubed x minus the integral of v du. Thankfully, du is just x. So we're going to have negative cosine x plus 1/3 cosine cubed x dx. I was sighing a few minutes ago because now we're going to have to anti-differentiate cosine cubed. So let's see, but we'll worry about that in just a second. So I'm going to repeat all of this. Okay, so I'm anti-differentiating negative cosine. That's going to give me negative sine, but I have an extra negative out here, so that'll be positive sine of x. And then I have minus the integral, minus 1/3 integral cosine cubed x dx. Ooh, and I'm not going to have enough space for this. So now we still have to anti-differentiate this. That's going to behave exactly like this one did, except for with a cosine instead of a sine. So maybe I could ask you guys to do this on your own. You should try it. I'll go ahead and do it up here. So like I said, this problem is messy. It's got a lot going on in it. So let's see, what are we going to get here? So we can divide this up into cosine squared times cosine dx. Cosine squared is 1 minus sine squared. Still have the cosine there. We're going to do a u substitution with u being sine of x. So my du is cosine times dx. So we get 1 minus u squared du, which will give me u minus 1/3 u cubed. And my u here was sine. Okay, so if we rewrite all of this, so we have x times negative cosine x plus 1/3 cosine cubed of x plus sine of x minus 1/3 times all of this. My u was sine. So sine x minus 1/3 sine cubed x all plus c. Whew. Okay, so that one was a lot, right? We had an integration by parts and then we had two separate trig integrals. So this is where I'm saying is that there is not one method to solve trig integrals. We have to get creative. Sometimes we're going to have to use multiple methods inside the same problem. And we're going to get lots of practice with these types of like mixture problems in class, just kind of getting comfortable with working with trig functions.